All right, part 2 summary right here. So you've looked at your data, you've worked on comparing the galaxies in terms of their wavelength, their redshift, their speed, and their light year. You did that all down here. Now we're looking at this last page. So we have a basic question coming from the data table that we want to make sure we have data for in our answer. Which galaxy was the most distant? So before I even look at the data, I should be able, when I see a question like this, to make my statement first, taking from the question. So which galaxy is the most distant? That's what I want to start with, right? The galaxy that is most distant is, and then look over here at our data. So distance is this column. You've got your number in here from your calculations below or your observations below. So figure out which one has the biggest distance and tell me what it is. Use the name and the number to support your answer, okay? This one here is saying, reminding you, a light year is looking at how far light travels in a year. So whatever this number is, well, that's how long it's going to take the light to get here from that distant galaxy. So the example we talked about in class, you know, is if a galaxy is 1,000 light years away, well, it takes 1,000 years for that light to get here. So whatever the number is you used up here, it's going to be the same. Here's where it looks like it gets tricky, but we can handle it. It says the most distant proto-galaxies have a redshift of 0.99997. So what we want to do is use that number to calculate what its velocity is, and therefore its distance. So it's almost like we're making one new column on that table. We're just doing it for the furthest galaxy possible, the furthest known galaxy, right? So we're taking this number, 0.99997, and we want to multiply it by the speed of light. And this is where it gets tricky. I'm going to encourage you to use the browser for this. I used my iPad calculator, but I couldn't do it as nicely. So I'm going to help you type this in, starting with our number, 0.99997 times, and then I need to get this number in parentheses in my equation. So I'm going to start with a parenthesis, and then 3.00 times 10, and I need that little 5 up here to the 5th power. So I'm going to use this button, x to the y, which notice gives me a spot to put in my 5, and then close the parenthesis. So this is what we should have recorded, and when you hit equals, you're going to get a number for velocity that you can plug in down here, and then finish your calculation by dividing by the Hubble constant. So you're going to do the same thing. Take that new number, which I'm not going to tell you what it is, divided by, and then you got to type this in again. So start with your parentheses, right? 2.30 times 10. Then again, we need this little button, x to the y. But this time, look, we need a minus 5. So I'm just going to hit minus 5 and close that parenthesis. And when you hit equal, you're going to get this big, long number. I'm going to recommend that you put in the commas so you can figure out what this number actually is. Remember, if there's 3 sets of zeros, or 2 sets of zeros, we're looking at million. If there's 3 sets, we're looking at billion. And see if that number looks familiar at all to you to help you with that number 14. I need to see this done and submitted before I see you in class on Monday.